Okay, thank you, gentlemen, for being part of this session. We welcome the viewers who are tuning in virtually to this second segment of the first day, and we will be covering on regional developments. Technology continues to deliver greater network capacity and reduce the cost to consumers in the Pacific Islands, as access to high-capacity international subsea cables, new satellite broadband services, upgrades of domestic infrastructure and coverage, a new generation of mobile technology, and more affordable consumer devices. For the Pacific Islands, 4G will remain the largest connectivity this decade, while 5G deployments will be first in the cities and then move out. We're looking at the next 5 years at least. And the shift to mobile broadband and 4G also reflects the increasing rates of smartphone adaptation, helped by decline in smartphone prices and the emergence of new and low-cost smartphone vendors. So while the subsea cable and satellite are both connectivity resolves the first mile, the challenges ahead will be on the second mile, IXP, regional IXP's data centers, and the last mile, which is the local access networks. And this is apart from strengthening the invisible mile, the spectrum, the cybersecurity, regulation, and domestic database. And the issues facing Pacific Islands connectivity, 9 million still or not connected or with limited access to internet, availability of sufficient spectrum, satellite and 5G, critical information infrastructure, and the impact of disruptions to that, so resilience in mediums, and of course cyber threats and social media issues. So these are just thoughts for the panelists as they present their views on IXPs, regional IXPs, 5G, internet, COVID, and cyber threats. But first, it is with pleasure to invite Mr. Masanori Konda, Kondo, Secretary General, Asia Pacific Telecommunity, APT, to deliver his remarks.
Okay, thank you, George. Can you hear? Okay, good. So can I share my screen? Yes. Okay. So now I hope you can see my slides. Can you? Now, is it okay? Okay, good. Once again, thank you, George and PITA, for inviting me to this very important event, especially to this session, regional coverage. So today, as APT, I would like to introduce the APT strategic plan, especially to focus on the Pacific perspective of that. So APT has just started to implement APT strategic plan for 2021 to 2023, which was adopted last December. And APT, as you know, APT covers Asia and the Pacific, and has, as its name stands for, and it has a huge diversity with potential. So today, I'd like to focus on 2 points. First one is just briefly introduce what is the APT strategic plan for 2021 to 2023. And the other point is to a perspective of the Pacific countries of this APT strategic plan. So briefly introduce APT. So APT covers 38 member countries in this region, from Iran to eastbound. And we have 140 so-called affiliate members, which is private sectors, private companies, and so on. So as a mission, our mission is to maximize the benefits of ICT for the welfare of the people in the region, and to foster the development as well as develop regional cooperation and so on, which are mentioned in our constitutions. Then, as a role of APT, it's a triangle of international policies, namely policy coordination and capacity building and ICT development. So what is APT strategic plan for the coming 3 years? we identified 5 pillars, namely connectivity, innovation, trust and safety, inclusion and capacity building, as well as collaboration and partnership. So for connectivity, it aims to enhance access and efficiency of digital infrastructure. So in order to do that, we consider that it is important to increase access to affordable, sustainable, and resilient. And it is also important to focus on the aspect of broadband infrastructure to underserved and unserved areas. Then, in terms of under the next pillar is innovation, which aims to enable conducive environments and harnessing the benefits of telecommunication and ICT. So it is important to foster the development and adoption of new and emerging telecommunication ICT and its standards. And also it is also important to harness the benefits of telecommunication and ICT. So the third pillar is trust and safety. So for us, especially for this region, Asia and the Pacific region, under this trust and safety, we focus not only cybersecurity and those kind of things, but also disaster management. So as you know, this region is vulnerable against natural disaster. So disaster management in the aspect of preparedness, risk reduction, and mitigations is also important. And the fourth pillar is inclusion and capacity building. Actually, for us, capacity building has a big part of our activities. There are more than nearly 30 to, around 30 training courses every year in China, in Japan, in Korea, in Thailand, in India. And there are so many trainees every year. For instance, last year, because of COVID-19 situation, we transformed the how we conduct capacity building program from physical one to virtual one. Then the participants increased more than 2 times. So the needs for capacity building is always there, and it's increasing. And the last pillar is collaboration and partnership. So we collaborate many international organizations, NGOs, and universities, and the government itself in the field of ICT in this region in order to deliver our services to our members. Then what would be the perspectives of this APT strategic plan? How APT strategic plan is interpreted in the context of the Pacific. So because of COVID-19 pandemic, the importance of ICT and what it enables us have been well shared by people in general. So at the same time, this situation clearly illustrates the digital gap in terms of accessibility, affordability, and digital gap. So this graph illustrates the situation of the Pacific for percentage of connections and subscribers in the Pacific countries. This data is from GSMA intelligence. So as you see, I just pick up the mobile broadband figure and mobile internet figure. So this graph illustrates the importance of internet broadband, specifically as you see, the the figure of 2021, it increased. It's only to first quarter of this year, so it increased a lot compared to the previous years. So this means that the degree of demand for mobile broadband is quite substantively increasing, and it shows the importance of broadband and, more fundamentally, connectivity itself. Then next slide, this slide shows the comparison between the Pacific and other member countries in this region. So let me focus on the mobile broadband. So as I said, even compared to other regions, the degree of increasing in this mobile broadband is bigger than that of the other region in the Pacific. So we can this graph can tell that broadband connection is demanded a lot, and at the same time there is still digital gap between if you compare the situation in the Pacific and other region. So which means when we interpret and apply our APT strategic plan to each member countries, specifically to the Pacific, the priorities of policy agenda could be different from country to country. So as some of the the example of data for mobile broadband and mobile internet, connectivity could be one of the most important priority things for the Pacific, especially broadband. And considering the situation of COVID-19 pandemic, now the connectivity is crucial to provide the necessary services for education, healthcare, and some other social public services. So how we consider and transform those priorities into policy agenda? Just pick up the example, connectivity. So connectivity, we may have several issues, but let me focus on accessibility and affordability. So each country may have a different way to approach it, but at least as a guidelines, there could be some policy issues or policy guidelines in the field of infrastructure and expansion of infrastructure and those kind of things. Then that is one hand. Accessibility could be one hand, and the other hand could be affordability of the access itself. So as a government, we may need to consider what would be the good way of policy combination, policy and regulatory combination for smart investment of private sectors. While as a government may have its own role to support digital gap or universal services and so on. So when we consider affordability of the access to the internet or to the ICT services, that can be identified as basic human needs. Of course, it depends on the society and it depends on the country, but this is just an example how to interpret APT strategic plan into each member countries, and each member countries may focus on the policy agenda and so on. So in such a way, we believe that APT strategic plan can provide a good guidelines for each member and how to digest and transform it in the context of each countries. So APT and APT Secretariat is ready to collaborate and cooperate with each member countries, especially in the Pacific countries, in order to provide good services and deliver necessary ICT infrastructure and services, including capacity building. With that, I conclude my presentation, and I hope that this information will provide some food for thought for the following speakers' presentation, as well as a fruitful question Q&A session. Thank you.
Thank you, Mr. Masanori Kondo, the APT General Secretary, thanks for sharing APT strategy and your thoughts in terms of the Pacific Islands. Estimates show that 90% of the global population live within a mobile coverage zone, but only 50% have internet access. So in terms of affordability and also awareness and education is key to seeing that coverage. Thank you again for your presentation and your participation. And now we move to the panelists that will be presenting their topics in the perspective of the Pacific Islands in terms of developments, solutions, policies, and strategies. And first up, something that is close to PITA in terms of our effort for the internet is the internet exchange in country and also the regional IXPs. And to kick off, the first presentation is Dr. Paul Brooks from UNESCAP, and he will cover Pacific Internet Exchange Point proposal. Thanks, Dr. Paul.
Thank you so much, George and Fred and the PITA community for the opportunity to showcase this proposal that I've been working with in conjunction with the local United Nations ESCAP office to look at a way of setting up a distributed internet exchange point so that many of the islands and the communities and the countries within the Pacific Islands community no longer need to send all of their traffic over to the US and back to connect to each other, but to try to keep as much traffic local within the Pacific area as possible. I will share my screen and hope that this will work. There we go. So as I said, this is an initiative that's been put together through the UN ESCAP office and working with the Internet Society as part of their Asia Pacific Information Superhighway initiative. Internet exchange, as opposed to internet transit or the broader networks generally, bring a number of benefits. And I was particularly heartened, we didn't coordinate this, but Kondo-san, this project basically hits every single one of those 5 pillars of the APT agenda in terms of local capacity building and bringing ICT back into the local community. By setting up internet exchanges, the traffic within the region can stay local, which improves performance because traffic isn't traveling over to the far side of the planet and back again. It also improves cost by reducing the amount of cost of transmission links and internet transit that organizations need to build. By aggregating the networks and the eyeballs of all of the smaller communities together, it makes the area much more attractive for content providers, the big majors, to bring their servers and their content into region to improve performance for the viewers and to encourage the local content and organizations to host their websites and their services locally. That means then employing local engineers, training local people to maintain those local websites, to do the web development, to do the content generation, and building that general ICT capability within the area. It's surprising how much effect improving latency, reducing the distance the signals travels can have on the performance of internet traffic. Above a certain level, increasing bandwidth, increasing link size has very little effect on the performance of downloading and browsing a typical website. Once you get beyond sort of 2, 3, 4, 5 megabits per second, additional bandwidth increase actually doesn't make a great deal of difference. But by reducing the latency, by reducing the end-to-end delay between the server and the eyeball, every single 20 millisecond of improvement can almost double the performance of the website. Latency and the reduction of speed of light delay makes a huge difference in the performance of the internet. Now, we already have a couple of successful internet exchanges, national internet exchanges in the Pacific area. PNG's internet exchange and Fiji's internet exchange have been running since 2017, been very successful, and have demonstrated the benefits of having a hub point, a central point that all of the providers within the country can connect to and keep local traffic local within the country, regardless of which service provider they're connected to. This proposal essentially brings that benefit to the whole wider Pacific Islands area. What we're looking for is an area that has, to minimize latency and improve performance for all the Pacific Island nation, not just the ones sort of near the geographic center, and build that business, as I said. Now, this is part of the UN SCAP, the Asia Pacific Information Superhighway sub-regional implementation, and started with a master plan back in 2019 through 2020, and I got involved in 2019 to do some of the technical engineering to work out the feasibility of whether it was actually possible to build something like this that would benefit not just one country, but all of the countries within the region. Turns out when you look at the Pacific Islands, they tend to fall typically into two fairly distinct geographic groups. There's a northern group that generally hubs around the island of Guam, and the southern group, which there really isn't a well-defined center. For the northern group, it actually makes sense. All cables lead through Guam. Guam is the central focal point for all of the connectivity, all of the cable connectivity within that northern area. And there are already internet exchanges in Guam. So for the countries in those areas, it makes most sense for them to already connect on the cables they've got into Guam, connect into the peering points that are there, and use that infrastructure to exchange traffic between each of the different islands, between each of the different countries. In the southern area, it's not quite so simple. There is no obvious hub. So what we did is redraw the topology of the subsea cables in the southern Pacific area, and each one of these lines is proportional to the speed of light latency, that basically the transit time along each of the existing and some of the proposed and soon to be finished cables in the area, to get an idea of a topology graph, which countries can connect to where, and what the latency is between each of the points. Now, the important thing when looking at a map is that the map can be deceiving when it comes to the looking at a subsea cable. If you look at the Hawaii cable between New Zealand, Australia, up through to Hawaii, and picking up a number of branching points along the way, it looks like each of the islands, if they connect to that cable, American Samoa, Tonga, Fiji, New Caledonia, could connect to each other, as well as to the points on the end. But it turns out that doesn't quite work. If you look at a straight line diagram of the cable, there are several fiber pairs within the cable, and it turns out that all of those branching units proposed for each of those islands connects only to one of those fiber pairs. That's the green one on this diagram. And that green one doesn't connect to Australia. That green one connects between Hawaii and New Zealand. So each of the island nations that connects via a spur cable onto the Hawaii cable, the only way that they can connect to Australia is to come via New Zealand, trombone out of the fibre in New Zealand, turn around and come back into the other fibre, the red one, and get to Australia. So for the point of view of a peering connection, it makes no sense for an island to seek to connect to a peering point in Australia, because it would actually be quicker to connect just to New Zealand. The traffic's got to go through there anyway. The other wrinkle is that each of those islands is connected to a different wavelength channel on that fibre pair. So they can't talk to each other either. The wavelengths just don't join up. So on this cable, American Samoa and Fiji can't actually talk to each other. They have to go via an endpoint in New Zealand or Hawaii and bring the traffic back to go to the other island. That's what I mean. If you look at a subsea cable just on a map, looks can be deceiving. The Coral Sea cable between PNG, Solomon Islands and Australia is the same boat. There is no way to connect directly from PNG to Solomon Islands. All that traffic has to go from PNG down to Australia and back up again if those two are to talk to each other. Southern Cross Next, due to come online next year, has exactly the same issue. If you look at a map of Southern Cross Next, Kiribati, Tokelau, Fiji can't talk to each other directly without going via the end of the cable. And that means when we add that onto the map of all of the other subsea cables in the area, as far as those countries are concerned, it looks like 4 separate cables. They can only talk to New Zealand or the US. They cannot talk to each other. So saying that, we put the picture together and looked at where is the point which minimizes latency for all of the countries in the Southern Pacific area. And it turns out New Zealand is not the right place to put it. Fiji, Samoa, very, very similar performance. There was no real way to distinguish between them. But if we set up a distributed internet exchange, which uses those 3 separate countries as anchor points, as a hub for all the other nations to connect to, we get a minimized latency of around 26 to depending on how you measure it, per population or just raw speed, 26 to 20 milliseconds from any country in the region to their nearest exchange point. So what we're proposing is a distributed internet exchange, a single organization that runs an internet exchange with hub points located in Fiji and Samoa and New Zealand, and them to be joined together via the subsea cables in a ring, which also has the benefit of running the system in a diverse loop. If there's a breakage on the subsea cable, the traffic can spin around the other way on the other links, and the internet exchange point as a distributed whole still keeps running. And then each of the countries we propose would then connect into their closest hub point, and from there get access to all of the routes and all of the traffic for every other country and every other service provider that connects into this infrastructure using the closest point. So this is a fair proposal because it means each country, no matter how far they are from wherever they are, only needs to connect to the closest point, and they can pretty much do that with a connection on a single cable. There's very few countries that need to do multiple hops through multiple cables to connect to one of these nodes. They don't need to connect to all 3, just the closest one. We get some economies of scale from the bandwidth because we're aggregating the traffic from multiple countries and multiple service providers together. And as we all know, the bigger the link you buy, the cheaper per gigabit the bandwidth is to carry that traffic. And we get optimized latency because if multiple service providers from one country hook into the same point, that traffic stays in that point and takes the shortest possible path, so we minimize the latency there as well. We get the diversity benefits that I talked about before, and by connecting into New Zealand and making New Zealand part of this distributed infrastructure, the internet exchange points in New Zealand are already very well established, and the major content locations, Akamai, Facebook, Google, Amazon, all those guys are already present and already connected to those exchange points. So by picking those up, we get the benefits of all of those connections in region already for every country. Every service provider can find their way to connect to the exchange point. So the Pacific Islands IXP is definitely feasible and a worthwhile benefit. As an operating principle, we're proposing it be set up as a not-for-profit cooperative. This is a very familiar model for how internet exchanges are run. The only thing that's different about this model is that it's distributed across 3 different countries. Distributed internet exchanges are actually quite well established. Many of the internet exchanges in Australia have 15 nodes scattered across the country. New Zealand the same. The international aspect adds a very interesting wrinkle, but from a technical perspective, it's all very, very doable. So with that, I'll pass on the floor and take questions either now or at the end of the session after the other speakers have spoken. Thank you very much.
Yeah, thanks, Dr. Paul Brooks, UNSCAP. Just a question in terms of your next steps. Any timeline when we'll actually see this distributed IXP?
We've gone through some fairly extensive consultations with the countries and the regulators and the government representatives for telecommunications in Fiji, Samoa, and New Zealand to make sure that we can set up those hub points. And you've been part of those discussions, and we thank you for that. And really, the PITA community are key to getting the word out that this infrastructure is coming. The next steps really is to make sure that the service providers and the telcos in each of the countries, because the benefit for this is not actually for those 3 countries, is the benefit actually comes from all of the other countries that can use this infrastructure as the hub, in a wagon wheel approach, to get access to a much wider community and a much larger amount of traffic within region than normally they would be able to expect to be able to gain access to. So there's still a while to go before the infrastructure itself is established, but because these 3 countries, Fiji, Samoa, and New Zealand, already have well-established internet exchange, or in Samoa's case, well-established plans to set up an internet exchange, the physical infrastructure in terms of a room, a data center, staff that's trained for how to make connections into an internet exchange point, those things are already well established. So I would hope that we'd be able to get some concrete progress on this proposal over the course of the rest of this year, and maybe start setting up physical infrastructure and getting boxes plugged together early next year. And I note that there is a big meeting in Samoa in December, I believe, and hopefully we'll be able to travel and actually be able to meet in person to progress this in a very concrete way.
Yeah, thank you again, Dr. Paul Brooks from UNSCAP. IXPs, regional IXPs, something very close to PITA. We are exploring the same for roaming as well. So from Pacific Internet Exchange point to 5G specifications and considerations, one of the key challenges for the Pacific Islands is the availability of sufficient and flexible spectrum, especially on satellite and 5G, thus our active participation in the WRC. So to talk about 5G is Amir Riaz from ITU. Whilst we get the presentation up, just for the information of those who are viewing this platform, at the last count to around 52. If you do have any questions, please make use of the chat forum in this platform.
So thank you, George. Let me try this, please. So in this presentation, what I will try to explain is something on 5G, some of the considerations, specifications, what 5G should be able to do, how it's different, and some of the ecosystem and considerations for regulatory and policy level, and also for the operators, what should they do to have the full 5G ecosystem in place. First, let me go to the definition. In ITU, we use the term IMT to define different versions of the mobile generations. For 5G, we use the term IMT 2020 that is roughly correlated with this, and all our standardizations and different reports and recommendations that are issued, we use the term IMT 2020. So in ITU recommendations, if you are searching for anything related to 5G, search for IMT 2020 and you would get the related information. From a point of view of what it can offer, there are different ways it can. It is different from the IMT Advanced, which is the 4G LTE Advanced, and three major use cases are there. You have seen the famous triangle, but the main idea is that it could provide enhanced mobile broadband, ultra reliable low latency communication, and massive machine type communication. And our standardization activities have been occurring based on this. In last November, I'm just trying to make it full screen. Let me try there.
You need to press on the start show, yeah, at the bottom.
Yeah, but it's not going. Somehow it's not going.
Oh.
Let me try checking the screen.
Hello.
Can you see now?
Yes, that's fine.
But it's not going now. Okay. So in our specifications, last November 2020, the ITUR study group had defined the standardization and they were agreed. The proposals that were provided to us, they have been evaluated based on the agreed criteria, and three standards have been adopted. Basically, there are 3GPP 5G SRIT, 3GPP 5G RIT, and 5GI that is submitted by the Telecom Standards Development Society of India. The 3GPP, the first two have been submitted by 3GPP, so it's not something that is coming from one administration or sector member, but it's a combination of standards that is coming. And RIT stands for radio interface technology. So SRIT, set of radio interface technology, and RIT is radio interface technology. These have been evaluated to fully fill the criteria that has been established by ITU. Go ahead. Okay. Going ahead. Somehow getting some problem. Not going ahead for me. Can you see the screen? I can't. Somehow it's.
Yes,
Yeah, we can
see
it's going.
all right. You.
It's stuck on my end. I'm trying to share one more time. Okay. Sorry for that. So let me go to the requirements that have been established. I will not go much more into the details of all the requirements, but some of the ones that are related. the user experience rate. So the peak requirement for the user experience rate is 20 gigabits per second for the downlink, and for the uplink it's 10 gigabits per second, but the average experience rate should be 100 megabits per second and 50 megabits per second. So since it's related to the data rate, so this has been evaluated for the applications that come under the enhanced mobile broadband. In case of spectrum efficiency, the download speed spectrum efficiency is considered to be minimum for enhanced mobile broadband specification for 30 bits per second. But there are, for average, there have been different scenarios in which the minimum average spectral efficiency has been evaluated, and these have been mentioned in the table below. If you want to go into the details of how they have been calculated, I have added the source, and I will share the presentation with you as well to see how they relate to different scenarios in the rural, indoor, or urban or dense environment. Then other specifications for connection density, which is especially related to the massive machine type communications. The minimum requirement is 1 million devices per square kilometer, and latency requirements are for evaluated for two specific use cases. In case of the broadband and the high speeds, the minimum requirement is 4 millisecond, but for ultra reliable low latency communication, it has to be around 1 millisecond the latency. Finally, some of the issues on reliability which have been evaluated for ultra low reliable low latency communication and mobility scenarios have been for indoor hotspots, dense urban environments, and rural enhanced mobile communications. But if you see in the table below in the chart, for example, for rural enhanced mobile broadband communication, the mobility limit is 500 kilometer per hour, but it goes low if you go to the indoor hotspot. So there are different scenarios in which this has been evaluated. These all three have been evaluated, and right now they are under this process of further adoption and confirmance by the administrations. Now, in the use cases, what we have seen that the major use cases can be divided into three sectors, and the uptake currently is coming from technology specialty area. For example, in case of Korea, the major traffic that is coming is from the gamification business model. But in other countries, the model of 5G is different. For example, in China, the drones, they are taking up a lot of space and traffic in case of the deployment of 5G. Similarly, what we have seen in parallel that these use cases, they will come into light and they will be enabled as we go along. As the coverage, it will go from urban to rural. We would see highly reliable and low latency, but in the beginning, the major use cases would be fixed mobile broadband, and this is something that is getting a lot of attention in developing countries as well, because due to the COVID, there has been a huge influence of population moving from the urban centers to the suburban areas, where there is, similar fixed mobile broadband is not at the same level as it in urban areas. So this is the case where 5G deployment is making a business case for the operators, especially in the developing areas, in the developing countries. And I will show you some of the statistics specific for the Asia Pacific that has been done. Now, what we see the 5G as an ecosystem, which is driven first by the input of the spectrum, which creates the infrastructure and the business and the devices, followed by services, and to create an impact and upscale the impact, we will need more spectrum. But in all of this, the inbuilt requirement is that of security, because this security is not only required for the infrastructure, but also the devices and services, because of the way different infrastructure is being processed from the physical to the logical application and layer. So the basic requirement right now, what we are going is to define the spectrum, and at the global level in ITU, we have different bands that have been identified. in the WRC 15, up till WRC 15, around 1.8 gigahertz have been defined, majorly in the spectrum that was below 6 gigahertz. But in the WRC 19, the millimeter wave spectrum was identified, and now we have around 19 gigahertz of spectrum that has been identified for 5G services which could be used. And going to the uptake of this 5G, what we have seen, this data is coming from the open signal. What we have seen, there is a lot of uptake in different countries. But if you see from the user experience, the countries that have topped the chart, they are coming from the Asia and the Pacific. Generally, these are the countries which have deployed the 5G very recently. For example, Thailand and Philippines. They have there the users have seen a lot of difference in the enhanced experience in case of videos or video experience or the download speed. The countries which have deployed it earlier, they are a little bit lower in the chart, but still there has been a lot of difference in cases of the user experience shifting from 4G to 5G. In case of usage and coverage, the 5G availability, it's considered by OpenSignal as something that is both someone who has both a 5G smartphone and a service plan, and how much at the time it is the individual is spending on the 5G. But the reach is something that is availability in the term of the coverage area. Now, if you see closely, the countries that are topping the chart in these cases, they are generally countries with a smaller geography, except for USA in the reach cases. And the major reason for USA is that they are using lower spectrum in the 700 for the 5G deployments. Otherwise, mostly the countries with the availability and the reach, they are countries with smaller geography. Some projections from the global data that we have, the devices that would be available in Asia Pacific, they are going to be exponentially uptake, and this is something that is that we are already seeing with the coverage in developing countries for the 5G getting into it. Now, coming to some of the challenges and some considerations. One of the some of the considerations that I have divided into three terms. One is on the spectrum, because this is one of the biggest challenge for deployment of 5G cases. There are some things that the national regulatory agencies can do. First, in case that there should be a clear roadmap that should be available. Spectrum sharing should be available, because in some of the cases there is a convergence of ISPs and the traditional mobile operators. So making spectrum sharing available is a win-win situation for all of them. Spectrum pricing has to be redefined, model has to be redefined, because the requirement of bandwidth is high, and if we use the traditional models, the business case for 5G would not take up. Similarly, 700 megahertz spectrum is something that is highly needed to give good coverage of the areas. So one of the major issue that we see for the 5G is the absence of backhaul. Here there have to be some of the policy interventions that should be done. Wireless backhaul is one arrangement that could be done. Fiber techs could be removed, and one of the innovation that could be brought in is the wave leave agreements or the right of way agreements. If there is a standardized way of leave agreement, because there has been the case of 5G in which the deployments are on the street furniture. So if their way leave agreements are standardized across different provincial or the district governments, then it becomes easier for the operators to deploy the backhaul. In case of sharing, the access and passive sharing has to be there, and an asset database, if possible, should be made available by the policymakers, so that if the passive infrastructure or the infrastructure at this the CCTV posts, lamp posts, we have the asset database available at the city level or the city or district governments, that could be very essential in deployment and the coverage of 5G to be available. As you can see, the lamppost, the traditional lamppost coming up, the modern innovation, you see, it's not just providing only the light, but it is a fully innovative 5G solution that is coming up in the new deployments. Similarly, 5G test beds are very much important, and here the role of academia and the innovators come in, because they can provide some models and more understanding on the business cases of the requirements of the individual countries. Now, I understand in case of Pacific and other developing countries, it may take some time, but there are some challenges already. So, like, for example, addressing some of the public apprehensions across the 5G. Some people have different issues. That is a miscommunication. To address this, we in ITU have prepared a kind of a guide, which is available in the form of an app, and this is available at the the address that is given in the source. This is available in all the 6 languages, and some of the countries, they have found it very useful to convert it into local languages. And for example, in case of Malaysia, the regulator has developed the same app in the form in the local language, and it's available to address the public apprehensions. To address some of the skills and the capacity challenges, we are organizing a lot of trainings. This year, I have highlighted some of the ones that are more related to the 5G. You will see that due to the travel bans, we have moved it on to ITU Academy, so they are virtually available. Some of them are totally free, and I will encourage all of the participants to join this meeting to have a more understanding on these issues, especially on the human exposure of the 5G related issues. I will stop at that. Over to you, moderator.
Yeah, thank you, Amir, for those information on and updates on 5G, and especially on the key issues for consideration in terms of the policymakers' backhaul fiber and fiber text. And also, PITA is keen to accept an offer on capacity building and skills in terms of what ITU has offered for training. So from 5G, now we move to Kevin Redmond of Mesa, Australia. COVID has seen the increase in data. For some countries, it's gone double digits. But with it comes the threats as well, which Kevin will highlight in his presentation. Thanks, Kevin.
Thanks, George. Bulla to everyone. Can you see my screen?
Yes.
Excellent. Okay, so thanks everyone, and it's always good to build on what people have spoken about before. So I'm just going to give an overview of who Mesa is, so you can understand that first. So Mesa's been around for 45 years, working across Australia, New Zealand, and the South Pacific, privately owned, and provides a range of different solutions, going from RF solutions like antennas through drive testing solutions, check coverage, to various things on the IT side of things for ISPs and telcos, looking at network management and traffic management, which is what I'm going to focus on today. So I'm not sure how many were with us 2.5 years ago when I done an overview of the Sandvine internet phenomena, but this is really an update on it, really looking at what the changes have happened to the internet last year around COVID, and more generically around how the internet is being used. Sandvine, for those that don't know, is the leader in active network intelligence, very focused on what applications are being used and what the customer experience actually is. We've spoken a lot about connectivity, which is, as we all know, an absolute must. But as was actually mentioned by Paul, just throwing more bandwidth at things doesn't work, and we need to understand what people are actually getting as a customer experience for their different applications. So for that reason, it's very important for all of us, telcos, regulators, and indeed ISPs, to understand the application that is being used. So with that, I'll just go in a bit more to the detail. So a bit of background on the actual where this information actually came from. So this information was gathered across 150 different mobile and fixed operators across the world, looking at a range of different things from about applications, what the overall tonnage is for the internet by category, what things are growing, comparisons between data rankings between January, February, March and June. And indeed, if anyone wants to see the detail, we can provide that. But I just want to pick out a few of the key features. So one of the things that we've really seen over, I guess, the last year is where the internet is being used. So prior to COVID, there were a lot of the internet was used on corporate networks, and therefore it was seen on corporate networks. That's where a lot of the traffic to the internet was, and then they had good connections into the backhaul, etc. What's happened is more and more people have worked from home, people have not traveled, and what that's meant is that more of that internet and the applications is being seen on the mobile and the fixed networks in people's homes. So it's happened really quickly. It's maybe not quite so much in the South Pacific, but it's definitely been a general trend we've seen. Just talking about some of the other things we've seen, the network growth. Network growth has increased. It continues to increase. 91% increase on the downstream. Part of that is due to people doing more stuff on the mobile and in the mobile broadband, which we heard as important, as being very important. But probably another thing that sort of has been highlighted very much is the increase in the uplink. I'll talk a little bit more about that, but whereas prior to COVID, you really looked at a lot of the traffic on the internet was very much downlink, very much around browsing and downloading information. Now that a lot more information, a lot more is collaborative and video streaming going up for work from home type applications, Zoom, etc. That's actually meant that for the first time, probably in a long time, actually making sure that you've provisioned your uplink and making sure you're managing your uplink has had a huge effect on the quality of experience that your customers are receiving. So we've talked a lot about, as I say, home networks now is where it is. Potentially for the Pacific, this could be viewed as on the mobile environment, but just picking out a few things. I've already mentioned that Zoom and video conferencing has been massive. So the growth, and this is worldwide, the growth of downstream traffic has been sort of 400% on video conferencing, and almost 250% on upstream traffic. For the Zoom particularly, it's gone up by almost 2,000%. Within our the discussions this morning about in the COO overview, there was talk about virtual schooling, and you'll see that the virtual schooling with Google Classroom has doubled pretty much in the last year. So putting a lot more pressure on telcos and ISPs to provide that capability, and to be honest, to provide a good quality of experience for those sort of applications. We looked at making certain websites free, but it may actually be that they need to be prioritized. Gaming continues to grow, video streaming continues to grow, and very much this generation has become a video first economy. Looking at the work from home, the fixed impact on work from home, here we're sort of seeing the downstream and the upstream. You'll see here that on the top, the enterprise, the actual overall throughput both on downstream and upstream has reduced over between January and June, as you would expect, as people to work from home. But the telcos have actually seen an uptick in the amount of downstream and specifically upstream traffic that they are having to deal with on a day-by-day basis. Looking at the teleconferencing type aspects, you will again see that what we're actually seeing is there was a large increase, but we're also not just seeing a large increase, we're actually seeing the peak times change. So whereas it was more in the evening, very much in the evenings, and it started later, now it starts happening much earlier in the day and goes on longer. Zoom, we've already talked about, has a massive growth, and this slide probably again reiterates what we're talk about comparing January to July. So you can see that both in the downstream and the upstream, there was a real increase, probably about 2 o'clock in the afternoon, starting at 9, it's going to 2 o'clock in the afternoon and dropping down. What you'll now see is that it goes up much quicker. So there is a peak at 10 o'clock, and then there's another peak which is actually at 6, 7 o'clock in the day. So not only do you need to consider that the amount of traffic has gone up, both downlink and uplink, but telcos need to consider that actually they need to be providing and understanding the bandwidth and indeed the latency, etc., for a much wider range of times and maybe multiple peak hours. Video streaming, one of the things we've again found on video streaming is the peak starts to happen earlier and earlier as we go through the year. And again, that might be because that people are working from home and they can actually do video streaming in their own, sort of take a half hour off to watch something in the middle of the day, rather than being at work. So again, it's fundamentally changing when people are using the internet and how people are using the internet. We talked about Google Classroom, and it's been mentioned that e-learning is one of the things that is now a must. Lots of schools are suggesting that we must go online, and whereas e-learning was at a particular time of the day, say about midday, 1 o'clock, now we're seeing that it's actually going sort of. The other thing we're seeing is that the e-learning is now being used for summer type programs. This is obviously focused on the US, where July is very much the summer. But you can see that again, the requirement is starting earlier and lasting longer. So that was just a bit of an overview of what we've seen change within COVID. We've also seen, with regard to people gaming, that gaming now starts at peak starts at 3 to 4 o'clock in the afternoon and goes on to 2 o'clock at night. Again, potentially because people are working from home and they don't have the requirement to get into the office. So that's some of our learnings from COVID. But now I just want to go and talk about some of the more general aspects that we've seen with what applications are being used. So top application trends. So really, Netflix is still huge, okay? But YouTube is the clear leader. I haven't got this specifically for the Pacific Islands, but from previous discussions and previous views of what's happening, YouTube is still the very much the clear leader for short form video. And sort of look at, and then Facebook comes a third, where the various forms of Facebook comes up to Netflix. One of the things that has happened in the last year or so is that TikTok has risen to number 8 worldwide, becoming a firm favourite for people doing stay-at-home orders. Looking at application, and unfortunately it only drills down to America, EMA and Asia Pac. We're not really seeing any difference in the application share. It's still YouTube, Netflix, Facebook, but Asia Pac has always had a very large contingent of people that use BitTorrent transfer. That has actually expanded in the last year, which you would expect because people are staying at home, have more free time, are more willing to download large transfers and basically watch videos, etc., on BitTorrent transfer. And telcos need to be aware of that increase and what effect it may have. And one of the key things I would highlight on there is because the BitTorrent transfer has increased, it's only increased 3.6% to 3.6 on the downstream, so still relatively low against YouTube and Netflix. But if you remember, I said upstream is a major issue. Because more people are using BitTorrent transfer, the upstream has increased to 20.8%, which is very significant. So just looking at the 3 main uses of the internet that we have found, they really fall, I guess, into 3 areas. The video traffic, which is still the most significant part of the internet, 50% of it. YouTube, still number 1. Netflix, as I say, has become a key component, although Disney and various other things. But again, TikTok is one. Those short videos that people do is now a very significant part of the internet. On gaming, there's no surprise. PlayStation, Xbox, and Stream are the 3 gaming applications. And Facebook for social traffic, which I think has become more and more prevalent and more used in this time when social connectivity is needed, is now without doubt the number 1, has gone past into the Instagram area. Just talking a bit about a video first economy, lots of people are using video all the time for all sorts of things. 2 of the things that have happened within video is people are now using Nest Cam for Ring, for doorbell, so you can see who's connecting, who's outside your front door without actually being there. And as you can see, a massive increase in the ranks. It wasn't really there before. New VPN applications like Global Protect. And I suppose there's been a bit of a wrestle between TikTok and Snapchat about what's the preferred method of actually connecting with people, and TikTok has very much become prevalent. And you can see there's some other times. FaceTime has increased, Skype's increased, WhatsApp's increased. People are using those video applications much more. And one of the things that's also not on here is, and we're working with lots of people on, is we work on OTT4, where things like Viber is stealing voice calls. So we need to be aware of the various applications that are being used. Video streaming, we've talked about YouTube. YouTube and Netflix are 90% of all video traffic. So although Amazon is growing, got 83%, although Disney has increased significantly across the world, Netflix and YouTube is the majority of the video traffic that's being used, and YouTube is probably less efficient than Netflix. So being able to manage that is very important, because YouTube, for instance, will always try to choose definition it can, and being able to manage what is actually needed by your users, because on a mobile it doesn't matter if it's high definition or not, is really important to both provide quality of experience and manage your throughput. Again, regionally, APAC, YouTube, Netflix, TikTok, very popular in Asia Pac, and others growing. Gaming. So I did mention this earlier. Gaming's increased by 40% in traffic. So continues to increase. Twitch, which is related to gaming, has produced a large upstream uptick. But the one that really sticks out and what we've looked at is, as I say, the gaming peak now starts earlier and lasts longer. So the idea of just having 2 or 3 hours of peak time, it's now like your peak is more like 8 hours for gaming, if not longer. The one that's interesting here is for APAC. Nintendo is much higher than it is everywhere else, but it's still relatively low compared to PlayStation, Xbox, and streaming. We have talked a lot about social interactions, and the fact that they are becoming more and more important for not just the health of telcos, but also the sort of social health. So again, don't want to go into too much detail because I've discussed it before. Again, APAC, nothing special there. There's some photo traffic. That's a brief summary of some of the things that we've talked about, we've seen in the past. If you'd like to talk more about where this information comes from, how you can possibly view this for your telcos, ITs, ISP networks, or talk about how we can look at quality of experience, please come and have a chat to us on our stand. And with that, I will pass it back to George and Vinaka.
Kevin, thanks for those insights on the internet and the impact of COVID. We've seen double-digit growth in terms of data and applications, but with that comes also the threats, especially on cybersecurity. The Fijian government in the last 2 days had their data center and website attacked. They had a cyber attack, and some of the sites had to be brought down. So to talk about cybersecurity threats, challenges, and opportunities, we turn to PITA, Walshman Key.
Thank you, George. Can you hear me?
Yes, I can see your presentation as well.
Oh, okay. Can you hear me? Can you hear my voice?
Yes, we can.
Oh, okay, cool. So good morning, good afternoon, good evening, everybody. And first of all, would like to thank PITA for having us on board. And it's our pleasure to be here to share some of our experiences and some of the things that we are doing, especially in the Pacific Islands. So just to give you a quick overview who we are, let's move on to the next slide. To give you an idea of who we are, Welshman Key, we are basically a strategic advisory organization, and our focus is on connectivity, where we look at areas into telecommunications, satellite communications. We look into areas of emergency services, and of course, cybersecurity. So I focus mainly on the cybersecurity portion of it. And one of the key areas that we look at is how do we actually try to build resilience in the critical infrastructures. And these are some of the things that we've been doing in the Pacific Islands, helping organizations to build capacity and capability in order to protect and defend against cyber threat. So the presentation I'm going to do today is just to go through some of the emerging technologies. What are some of the things that is we are seeing in terms of technologies that is happening? What are some of the threats that we face with these technologies, and how do we address this kind of challenges that we are facing today? So, so let me start with looking at the emerging technologies. Move on to the next slide. Right, the next slide, please. So we look at emerging technologies and opportunities, right? We can move on to the next slide, please. Thank you. If we look at some of the emerging technologies, and again, as Kevin mentioned, it's always good to build on what the other previous speakers have spoken on earlier. A lot of touch about 5G and IoTs and all that. So just to give you a little bit of statistics of the growth or the trends in some of these technologies, we see that areas like 5G and IoT, which are revolutionizing our lives today. If you look at the stats itself, we see that IoT is projected to jump from 17.7 billion in 2020 last year to 36.8 billion in 2025. Now, what it shows is that this is going to be a huge jump in terms of IoT devices. As we look around us, we see more and more things that are connected to the internet, and more devices are coming on board, which is good. These are all opportunities for us. These are all emerging technologies for us. The question is that, are we prepared to face the challenges that comes along, the threats that come along with it? If you see that enterprises make most of the IoT in 2021 with artificial intelligence and Wi-Fi 6. So if you look around you today, we are already on Wi-Fi 6. I'm already using Wi-Fi 6. AI is revolutionizing the world today with smart connections, smart connectivity, smart devices. And I will show you a little bit more, I'll talk a little bit more about it in the next slide. But so we see that IoT, 5G, Amir spoke a lot about the 5G technology this now. So 5G is growing. Some of the countries have started 5G. Some are in the process of implementing 5G. Some are in the process of putting it in place. So 5G is going to become the new standard in our communication. But of course, it's still not there yet, but it's growing. In some countries, it's already been rolled out. And we can see that Wi-Fi 6 will definitely be a big thing now with the connectivity speeds, going very, very high today. So these are some of the trends that we are seeing. But in these trends that we are seeing is that how do we use this technology, the harnessing of the technology? So you can see here that AI, AI is the technology that is actually adding a lot of value to IoT devices, as I mentioned. And we can see that with the introduction of machine language or machine learning, we see that we are introducing what we call as connective workflows. So these connective workflows are what we see are intelligent ways of doing things. We see much more things are being automated. If we look at a lot of CII or the critical industries, a lot of them are really now moving into full automation. What traditionally was semi-automated, or they try to do things which is not too much of using the internet, but today they have no choice. So that is why you can see that critical infrastructures today are moving from operational technology to information technology, and this is good because this actually enhances the work, the productivity. It also enhances the kind of work that they're doing to make it more efficient, more effective. And if you look at the point number 3 there, it says the level of intelligence will lead to faster, more informed decision making. And this is what we want today. What the world wants today is we want to make faster decision, we want to make informed decision, and we want to make the correct decision. And this is all possible with cognitive workflows. And cognitive workflows work well when we introduce machine learning, when we introduce artificial intelligence in it. So there's we can harness the technology that is available today. This connectivity is this technology is available because we are now connected. And you've seen in the previous speakers, they've talked a lot about in terms of the Pacific Islands, how much of connectivity has been going on in the Pacific Islands. Submarine cables are being laid. A lot of countries are now being interconnected. So what I would like to address is that while we have these emerging technologies, while we have this technology that we can harness for our benefit, we need to also be prepared for it. We need to be prepared that, it's like the saying, with great powers come great responsibilities. So with all this technology comes responsibility for us to protect our network even more. As I mentioned this now, when we talked about critical infrastructures, we see that in the early days of critical infrastructures, it was just operational technology. Many of these things were not connected to the internet. So people were not so worried at that time because it was hard to hack those kind of infrastructures. But today, with critical infrastructures moving more and more into ICTs, we see that they are now more open towards cyber attack. As George mentioned this now, the recent data center attack, and there's a lot more. So if you look at the next slide, just to give you a, the next slide basically shows you what has already been said earlier, but I just wanted to reiterate that we see that a lot of things are happening within the Pacific Islands. You see that digital network building in the Pacific. We see that cybersecurity is a big concern in the Pacific Islands because of connectivity. So if you look at some of the highlights I've highlighted there, like for example, if you look at cybersecurity in the Pacific Island nations, the rapid expansion of fast access to the global connected internet has also increased the risk of Pacific Island nations. So this is the key point that I want to say. So as I mentioned this now, as much as connectivity helps us or gives us the opportunity to expand the services that we do, to provide better, more efficient services, it also comes with risk. And in cybersecurity, we always say this, if we are not aware of our risk, then we are in great danger. So as long as we know that there are risks associated with it, we need to then know how to address this risk. So moving on into the next slide, we see that what are these threats and challenges? So to reiterate, as we talk about the new reality. So what is this new reality about? We see that this new reality has seen a rapid growth in people working from home. We see a rapid growth of new technologies coming into place. We see a rapid growth of cyber attacks as well. So if you look at some of the statistics here, we see that 91% of enterprises reported an increase in cyber attacks. because more employees were working from home. But why is there an increase? Because simple fact is that many companies were not prepared. Okay, many companies were not prepared to put in place the measures that is able to protect them as they work from home. Many did not have things like VPNs or proper security features. The tools were not equipped for their workers at home, and this has caused an increase in attack. So that is why we need to have a proper risk management done. We need to be prepared, and preparedness is very, very important. We see COVID-19 inspired malware saw the highest jump because people were using COVID-19 as their front to attack many of these people. So they would send phishing emails, spam emails that actually try to capitalize on the current situation. So this was where they managed to infiltrate many of the systems because they took advantage of the situation or the pandemic that was going on. And you can see some of the percentages there, countries that have suffered it. But let's look at the next slide. Can we move to the next slide? If you look at the next slide, you'll see that the next slide talks about how an assessment that was conducted by Interpol showed that COVID-19 pandemic has seen a shift of attacks from small businesses to critical infrastructure, governments, and major corporations. And this is my concern, and this is what I wanted to stress on. As I mentioned earlier, because of the pandemic and people working from home, attackers have taken advantage to attack critical infrastructures, to attack governments, major corporations. So the question is that, is it true? Is it happening that people, businesses were not prepared, that when more workers were working from home, it left their organizations more vulnerable to attacks? And these are the things we need to be prepared for. So I've worked with a lot of organizations during this pandemic, and some of them, they have some of these plans in place because they already put in place preparedness plans, business continuity plans in terms of pandemics such as this, or where workers need to work from home. So the question is that we need to be prepared. It's nice to be connected, it's nice to have a lot of technology, but it's also important for us to prepare for this. Another point I wanted to point on in the previous slide was the Deloitte mentioned about seeing the next normal, where sectors not classified as critical before are now being seen as critical. This is also a new reality. We see that in some of the food retail outlets, which was not considered as critical, is now considered critical. Because if you look at some of the countries like where I'm based at, we had lockdowns, and during lockdowns we relied a lot on food retail outlets, the normal shops, for us to get our food supply, drinking water and stuff. So they became critical. So countries need to be prepared to be flexible, to adapt to this kind of scenarios. So when there is a pandemic such as this, the new reality, we need to also look at, hey, is this a critical sector now? Is this considered a critical? Because now the sectors that were not considered critical previously are now being critical. Even the attackers were attacking the research labs that were doing COVID-19 research, and these research labs were not considered as critical infrastructures before, but now they were considered as critical infrastructure. So we need to look at the overall, we need to look at what needs to be protected, what is considered critical, what is not, what was considered not critical before, is it critical now during this time? Okay. Moving on to the next slide. This is just to show you the attack trends of 2020. I think it's very common. Social engineering will continue to grow. People are using this this whole thing to actually try to do more phishing attempts, malwares, and so on. Okay, we'll move on to the next slide in the interest of time. So I've got just two more slides just to talk to you. How do we address these threats? So we know that these threats are there. We know that organizations are open to these threats. We know that technologies are there. So we need to have a proper way or a proper measure to address this kind of threats. So I put together something that you can look at to look at this and how to basically come together and put this thing together in order for you to better protect yourself. So I put some 7 points there where we look at the risk management framework. We build and test emergency plans. We talk about training, awareness, and education, supply chain security, information sharing. Now, information sharing is very important, especially in a country in the area like Pacific Islands. So if we can have more information sharing in the Pacific Islands, that will actually help us to react faster. We are able to basically know what to do next quicker. In cybersecurity, it's all about getting information fast. The faster we get, the more faster we can actually put in place our measures and mitigate this risk. So in conclusion, we need to have a good capacity and capability building program. We need to have a good emergency and incident response in place. And importantly, we need to have proper national strategies and international cooperation. And last but not least, the information sharing itself. So if you have all these things in place, you would be able to better protect, defend, respond, mitigate to the cyber attacks that is coming. So I'm open for any questions if you have. Thank you very much.
Yeah, thank you for those thoughts, insights, and advice, Philip, from Welshman team. The last count, we had 56 who were viewing it. Don't see any questions in the chat box, but gentlemen, thank you again for your presentations, your thoughts and the insights, especially in the area of COVID-19 and its impacts, 5G, cybersecurity, and on the internet. So we thank Mr. Masanori Kondo, APT General Secretary, Asia Pacific, for his opening remarks. Dr. Paul Brooks, UNSCAP, Pacific IXP, we look forward to that implementation next year. Amir Riaz, ITU, 5G, and PITA thank ITU for the continuing training options that's been given, and we look forward to the 5G training as well. Kevin Redmond from Mesa, Australia, a platinum sponsor as well for those internet applications and interesting growth in various areas and applications. And finally, Philip Victor, cyber threats and what to look forward to in terms of the growth in data in digital technology, but also the threats that comes along with it. Welshman Key is also a platinum sponsor.